Okay, so show that the line y equals x plus 2 touches the curve y equals x squared minus 5x plus 11. Now, of course, when they touch, they'll have the same x and y value, right? So we can solve these simultaneously to work out what that x and y value is, right? So if they have the same y value, okay, essentially then we can put these equal to each other because the y values will be the same. Okay, so I'll say solving simultaneously. Essentially then the y's are equal, so x squared minus 5x plus 11 will equal to x plus 2. So what I'll do then is get everything onto the left hand side. Okay, put the x's together, take the 2 over as well, and I end up with x squared minus 6x plus 9 equals 0. Now when I solve this then, okay, I'm going to have two brackets. Okay, equals to 0, x in both. So I need to think of two numbers that multiply to give 9 and add up to give minus 6. So the two numbers are actually going to be the same, both minus 3, yeah? Minus 3 times minus 3 gives you plus 9, and of course they add up to give minus 6. Now you'll notice, because they're the same bracket, we could write this as x minus 3 all squared equals to 0. And of course, if you've got that, you've simply got x minus 3 all squared is 0. That means x minus 3 must also equal 0. Okay, you've just got one bracket, essentially, in this case, then equal to 0. So you've got one result, x equals 3. So if you've only got one result for x, you're only going to have one result for y. So if I sub into the second equation, this one here makes it easier, doesn't it? Quite simply, when we say, look, when x is 3, then y equals 3 plus 2, which equals to 5. Okay, so we've just got one result out. Okay, so given there's one result, that means then the curve on the line don't actually intersect. Okay, because if they were to intersect, you'd have to have two results out. So given one result, that implies that the curve and line touch at the point 3, 5, okay, at the coordinate 3, 5. Okay, the other way of thinking about it is the line is a tangent to the curve. So when it touches, it's a tangent to the curve at that point. Okay, now diagrammatically, right, if we've got a curve, okay, at the point 3, 5, you would literally then have a tangent then like that. Okay, so it touches it, doesn't it? Okay, at that point 3, 5, it doesn't intersect, because if it was to intersect, that means it goes through the curve, and if it was to go through the curve, it would have to go through it at another point. So you'd end up with two results then, yeah? Okay, but when you only end up with one result, it doesn't actually go through the curve, it just touches it, okay, as a tangent. So hence the reason why you have one result there. So we can say clearly then, with one result, we can confirm that the curve and the line touch, or rather the line is a tangent to that curve.